All right, hello everyone. This is John, and today I am sharing with you episode 3 of the Interpolation series. Similar to episode 2, this will just be a question for you to try and solve, and I'll provide the solution thereafter. So here is the solution. Find the percentile when the raw score equals 3. Feel free to pause the video at this time and resume once you've completed the question, and we'll go through the question together. And I'll continue to the solution now. So the first thing I want to mention is a bit of a trick with this question itself. It's asking for you to find the percentile when the raw score equals 3. I haven't really provided an example of this one at this time, so I wanted to use this episode to provide this specific example. Of course, because we're always dealing with those real limits when dealing with raw scores, even when you're asked to solve a solution that is at the bottom of a frequency table just like so, you can still use real limits to do so. In the previous episode, I mentioned just ignoring these first digits of the intervals, especially when you're trying to find a value in between intervals. But when you're asked to find a value that is at the bottom of a frequency distribution table just like this, you have to use both values in order to create those real upper and lower limits. So in this example, this interval would have its lower limit at 0.5 and its upper limit at 5.5. So that is the trick here. You're actually using the real limits within this one interval rather than trying to compare two intervals together. And now I'll go to the solution. Okay, so here is the solution to solving this question. The first step involves finding the width of the interval. As I was mentioning in the previous slide, you only have the one interval to work with here. There's not another interval on the other side. So in this case, those real upper and lower limits have to be 0 or 0.5 and then 5 or really 5.5. And now when you subtract the two together, it equals 5. Step 2 now is to find that difference between that upper limit and the value that is being asked for in the question. So in this case, we would subtract 5.5 from 3. 5.5 is that upper limit of the interval, and 3 is the value that we're seeking to uncover. And we get a value of 2.5. So now that we have the width of the interval, which is 5, and that difference between the upper limit, which is 2.5, now we have our fraction and now can go to the other side of the table now, which would be over here. So for step 3, we have to find the width of the interval. So what from 21.73 and below. And because there's nothing really below 21.73, it is technically 0. So 21.73 minus 0, of course, equals 21.73. So the width of the interval in this case is literally that number. So now that we have our values, we have the fraction from this side of the table, and we have the width of the interval from the other side of the table, which is over here, we can multiply the two things together to get a value of 10.865. And now with 10.865, we are technically asked to subtract that from that upper limit right over here, which is 21.73, to get, of course, which is exactly half, which is 10.865. And that is the answer for the percentile on this side. But something I mentioned in the first episode, which I didn't really cover in the second episode, but really wanted to emphasize here, some of these interpolation questions could be pretty confusing at times, especially when you're trying to figure out something near the bottom of the table. So it's always good to double check your work. Do the question now in reverse order to see if you get the raw score of 3. You want to see if your answer matches the original question being asked. And here it is. We are just now repeating the same interpolation question, just this time trying to make sure we can get the answer or a raw score of 3 on this side. So you could see literally we have to find the width of the interval, which is 21.73, subtract that from the value we received in our original answer, which is half, and then we get our fraction of 10.865 divided by 21.73. The idea is we're using this original answer from that we got when we first did this question, and now just plugging it back in. And now when we go to the other side of the table, we have 5.5 minus 0.5, which equals 5. We multiply them together to get 2.5. We minus 5.5 from 2.5, because with this difference here, we subtract that from the upper limit on this side, and of course we get the value of 3. So the question can repeat itself. You can go in reverse order to double check you got the answer correct. Thank you so much for watching this presentation.